Hello, welcome to another episode of Xan Talk Show. Xan Talk Show is a variety show, mostly focusing on programming and nerd stuff. So I talk about programming languages, in particular Emacs Lisp and the Wolfram language, and it also may include JavaScript, Python, Golang, and a bunch of others. Programming language design, algorithms, artificial intelligence, Wikipedia, information technology, this kind of thing. Nerds of interest to nerds. In particular, my interest. If you are watching offline, feel free to skip around. So because I talk, random-ish. And today we are going to code. Advent of code. What is going on with that? Advent of code. Okay. So continue advent of code in Wolfram language. Okay, let me talk about my keyboards and let's begin. So this is Glove 80, fantastic keyboard, my main. This is Ultimate Hacking keyboard, also fantastic. I use it as a macro keypad, 60 keys macros, fantastic. Nulia trackball, Logitech mouse, and I must mention this again. I have not, been using it yet. So this is SVALBOARD, SVALBOARD. This is the most advanced input device. It's a keyboard. Okay, so A, B, C, D, E, F, G, QWERTY, and VORAC, and there's a pointer. So this is called SVALBOARD, SVALBOARD. There's two of them, one for left hand, one for right hand. Hold on, and I will be using it every day. Okay, so that's my keyboards, and I have reviews. Just search for it. You'll find it on YouTube and all over on my website xali.info. Okay, today Advent of Code 2023. Other people finished in 2023. I finish next year. So previously we've done up to problem 9, day 9, and day 10. I skipped because I was tired that day, and this is kind of day 10 is tedious problem. So we're gonna do day 11. Okay, let's just begin. Okay, let's talking and begin coding. Okay, am I ready? Yes. Got coffee? Yes, coffee here. Advent of Code 2023, problem 11. Okay, day 11. Okay, let's begin. Let's start to make. We're gonna code in Wolfram language. Let's start Wolfram language. Wolfram language now version 14. Fantastic, the most powerful symbolic language on earth. A magnitude higher level than Haskell, Clojure, Lisp, OCaml, F#, all the languages. So Wolfram language. Okay, so start a new notebook buffer. So 3, enter 3, shift enter to evaluate. Fantastic. Let's magnify one more. Okay, so let's read the problem. Day 11. Okay, so day 11. Let's try to do this quickly instead of slowly reading everything. So you got problem input, looks like that, some kind of maze kind of thing. So Advent of Code, they like to do that. Okay, so you continue following signs for hot springs, and eventually came across a observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He will even take you straight there once he's done with today's observation analysis. Okay, idiotic elf. Maybe you can help him with the analysis to speed things up. Of course, the researcher has collected a bunch of data and compiled the data into a single giant image. That's your puzzle input, critical part. The image includes empty spaces represented by a dot and galaxies represented by a pound sign, for example. Okay, so a dot is empty space, a pound sign is galaxy. Okay, so you got the input like that. The researcher is trying to figure out the sum of the length of the shortest path between every pair of galaxies. Oh, combinatorial problem. So between every two pound sign, you have a distance, okay? And sum of the length of the shortest path between every pair. So every pair, you have a path in between them. That is, and then you have a length of that path. So you have variety of a path between a given pair of galaxies, but you want the shortest, of course. In this case, it's called taxi cab distance or Manhattan distance, because supposedly Manhattan, the city near New York, is kind of like all squares, it's grid. So instead of going like curved line, you just go up, you can only go up down each time by 1 unit of distance. So that way of measuring this distance is called Manhattan distance or taxi cab geometry, something like that. Okay, you can look up on Wikipedia. So anyway, shortest path between every pair of galaxies, there's a shortest path, and measured, given by a length, that's a number, and the researcher is trying to figure out the sum of the lengths. Okay, so you have a pair, you have a bunch of dots. Each city, each galaxy, let's just say it's a dot, okay, a vertex. So you have a bunch of them. You want to get a list of all the possible pairs. Order doesn't matter, okay. Now for each pair, you got a distance. That's the taxi cab distance, okay. Then you want to find out the sum. Okay, you want to find the sum of them all. Problem understood, I believe. Now, however, there's a catch. Oh, there's a catch, you fucking elf. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any row or column that contains no galaxies should all actually be twice as big. Oh, there's a trick. So if you have a row, or if you have a column, so for example, this row, where there's no galaxies, then anything passing through that counts as 2 distance, okay? Idiotic. Okay, these rows and columns need to be twice as big. The result of cosmic expansion, therefore, looks like this, okay? So the first step is you expand the universe, something maybe. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. Okay, now it's giving a number instead of the pound sign or the number sign or the octatrope. That's the name of that symbol. In these 9 galaxies, there are 36 pairs. How do you know? Because combination, because 9 times 8. Let's say 88648. Wait, what? So there's 9 galaxies. Oh yeah, then order doesn't matter. So 8 times 9 is 72. 72 divided by 2, because order doesn't matter. You got 36 pairs, correct? Only count each pair once. Order within the pair doesn't matter, of course. Shut the fuck up. For each pair, find any shortest path between 2 galaxies. For each pair, find any shortest path between the 2 galaxies using only steps that move up and down. Of course, yeah, that's taxi cab geometry. Or write exactly 1 dot or 1 pound at a time. Oh, but there's a question. Can you, when you pass through another, galaxy, do you have to go around or you can directly pass when you count the distance. Apparently you can just pass through. Yeah, okay. The shortest path between two galaxies is allowed to pass through. Is allowed to pass through another galaxy. I'm prescient. Even before I read the problem, I knew. For example, here is one of the shortest paths between galaxies 5 and 9. 5 and 9. Now, why do they draw two? Oh, actually, it's just one. Okay. So this path has length 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. Let's try count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you have 8 pound symbols plus 1. Because the last step, the 8 locations marked number sign plus the step onto galaxy 9 itself. Yeah, so here are some other examples show this path length. Okay, so in this example, after expanding the universe, the sum of the shortest path between all 36 pairs of galaxies is 374. Okay, you want to find the sum. Okay, expand the universe, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? Okay, that is the problem. Okay, this problem seems slightly complicated. Am I alive? Is there any disturbances in the universe such that my live stream is actually not live? Let's double check. Yeah, it's live. If you are here, say something. Okay, so this problem is slightly complicated. Let's get to work. Okay, let's stop talking because normally I'm too slow talking. So let's just get some of the input. Let's see. So of course you need the input and you need the toy input. So here is the toy input. So now, okay, so let's see. Okay, so here's the toy input. Okay, then let's see my puzzle input. Do they use, what kind of symbol do they use? Get your puzzle input. Okay, copy, and the new buffer save. Let's save it XX today's date advent of code aoc.text. Okay, now make a backup. Now expand the window. Okay, they use the pound sign for the galaxies. Okay. Okay, so first of all, you need to expand the universe. Okay, so this is my input. Okay, and here's the sample input. So so we can actually start to work on this problem. Yes, because I know all the specifications of the problem. So should we write it down first? So given, let's write it down because that is my habit, and it's a good habit when you actually work in real life in a job. Because I'm not the hacking type like the Unix and C idiots. They don't think. They just start to do something. They typically that's what they do. Start to. Fucking, I despise those. C and C++ and the Unix, the sysadmin, this type of people. Okay, I'm a engineer, programmer. I'm a mathematician. So let's start to write the problem. So problem given a text input. Each char is either a dot or a pound sign. You want to first double the row that's all dots. Okay, and double any column that is all dots. Okay, that's what you have to do. So problem specification. Okay, so that you expand the universe, then then okay, so the goal is to get the sum of all the distance. So you need to start to identify, you see, you need a way to identify each of these galaxy locations. Well, you can use a coordinate system, or you can just use, 1, 2, 3, 4 by order, top down, left to right, or you can use ABCD. So it seems 1, 2, 3, 4 is easiest. But then okay, then so you need to identify. You need to find a way to identify the galaxies. Okay. And then given two galaxies, you need to measure their distance. Now, how do you do that? Okay, Wolfram language can easily do it. Because wait. Oh, wait. So there's actually very simple. If you allow passing through any other galaxies, then then the distance between any two galaxies is just the sum of their coordinate difference, x-axis and y-axis. Instead of doing any of zigzag, all you have to do is just compute how many in the column, how many in the row. Okay. Okay, so yeah, you see, right now the problem is how do you codify this? So anyway, so first of all, you need a way to identify all the galaxies. Okay. Okay, so the easiest way is actually by coordinate, because you need to compute this distance later. So once you have coordinate, it's much easier to compute the distance. Right. So for each of these galaxies, you need to give it a coordinate, like Cartesian coordinate. So which is identified by two numbers, x coordinate and y coordinate. And also you need to devise, like, where do you consider is the origin. Okay. So typically origin is the bottom. So basically to get the coordinate for each galaxy, all you have to do is you count at what column it is. That is the x-axis, column number. Then the line number is the y-axis. Okay. Now that is assuming the coordinate is at the top left, and the y-axis goes downwards, positive. Okay, but anyway, that's how you get a coordinate. Does it matter? I mean, like, traditionally in mathematics, the y-axis up direction is positive. Okay, but usually in computer graphics, the y-axis up direction is negative. In computer graphics, usually the coordinate, the origin, is on the top left. So the more down, the more negative, the more positive it gets. So it's the reverse of the traditional math. So which way should we do? I mean, in this case, it's probably easier just to count down, so the first row is just 1 or 0. So second row is y equals to 2. Third row, y equals to 3. So in other words, any of the galaxy is identified by the column number first, then the row number. Okay. Wait, there are many ways to do this. Okay, you don't have to go into math coordinate. You can just say row number and column number. Okay, same thing. So let's do the row number and column number. So you have row number and column number, okay? Then the distance is, okay, so let's write it down. For each symbol, pound symbol, okay. For each pound symbol, it is identified by row number and column number. Okay, fantastic. Row start at 1, column start at 1, not 0, because 0 is the from this Java, C++ idiots. They created this 0 convention, which is very idiotic. It's more cumbersome to deal with 0. Okay. I have an article on that. Why does array start with 0 or 1? So physics, default Emacs key binding will fuck up your fingers. That's true. Okay. Now let's focus on today's problem. So you identify each of the galaxies by row number, then by column number. Okay. Here we documented the problem. Then what's next? Then the distance between them is just let's see. The difference. Okay, let's just write it down. Okay. Let's sum them all together. So the distance between two galaxies is the let's just write in the row numbers plus, okay, so something like that, column number. So difference between row number and column number, and plus 1, I think. So I believe that is that. Okay. So difference row number plus difference column number. Okay, let's try. So this the column difference is 0 and the row is 1, 2, 3, 1, 2, 3, 4, 5. So the second one is 5. The first one is column 1. 5 minus 1 is 4. Okay, so you don't have 2 plus 1. But in fact, you need 2 minus 1. Wait. Wait. So this is the off by 1 problem. Okay, I need to think. So let's see. So the difference between these two, 1、2、3，3减1，2，1、2、3，3减1，2。So 2、2、4 1, 2, 3, 4. Oh, 1, 2, 3, 4. Oh, so you don't have to add or minus. Okay, so so you don't have to add or minus. Let's make sure. So what about here? 1, 2, 3, 4, 5. 5 minus 1 is 4. 1, 2, 3, 4. That's correct. So yeah, so looks like it's correct. Okay, so yeah, so looks like okay. That's a difference. Now the other problem, you need to get all possible pairs of the galaxies, order no matter, okay? Then just sum up all their distances. That's it. That is the outline of the algorithm. Okay. Okay, let's start to code. Let's start to code. Let's start Wolfram language. Okay, input equals to that thing. It's a string. So it's a string. Then so the first problem is to make them expand the universe. So to find all columns. So let's think about how we want to do this. Oh God, this is tedious. It's gonna be 30 minutes or 40 minutes. Shit. So can you use regular expression? Yeah, but the problem is how do you find out all the empty columns? Now that would be a problem if you use regular expression. It's very easy to use regular expression to find all lines of a same symbol, but it's a problem if you have vertical, unless you do a transpose, like you flip this text. But in general, in most programming languages, you don't have a transpose function on text. In Wolfram language, you have a transpose function on matrices. But this is not a matrix, this is a text. So is there a transpose kind of function on a rectangular text? No, because that is in general, there's no such issue. So what you can do is you can convert this text into a matrix. So each element of the matrix is just a character. Okay, yeah, you can first of all expand all the empty rows by using regular expression. Then you turn this whole thing into a matrix where each element is a character. Then you do a transpose of the matrix. Then you turn the matrix back into a text, into a string, lots of, multi-line strings. Then you do the regular expression to find. Okay, that's one solution. You do this conversion to matrix back and forth. Okay. The other solution is that seems to be the easiest solution, but not necessarily the fastest. A more tedious solution, more direct, is you just manually get the character of each column. Then you get the same character, the same column, the next row, same column, the next row, next row, next row. If they are all the same, then you insert a row. Yeah, you can do that. So the code will be a loop. Well, I mean, well, yeah, it's tedious. It will be extremely easier if you just convert it to matrix and do this transpose, okay? Now let's think about if we convert to matrix, can we walk directly in the matrix without converting it back and forth between matrix and text? Now, if we convert this to matrix, how do you find out if all rows are of the same character? Very easy, okay? Also, how do you find out all columns are of the same character? Very easy. And how do you insert a new row or new column? Very easy, okay? So now it's decided. Let's convert this to matrix, okay? Okay, so now the next problem is in Wolfram language, how do you convert a text, like that to a matrix? Of course, there are many ways. But let's see if there's a built-in function, okay? Matrix Q, matrix this, matrix form. Okay, this is 100 functions for matrix. Let's see. Yeah. Well, why don't you do multi-column? Yeah, okay. So matrix form, adjacency matrix. Let's look up what is that. Adjacency matrix give the vertex-vertex adjacency matrix of a graph. Okay, that's converts a graph to matrix. Okay, so there's a lot functions on matrix, but what we want is some kind of function that converts a string to matrix. Maybe there is, maybe not. I think probably not. Okay, but still, it's good to look at this thing because later on, eventually, we'll need, we'll kind of need some matrix functions. Scaling matrix, rotation matrix, path 3D matrix, distance matrix, okay? Distance matrix gives the matrix of distances between each pair of elements. that solves a major component of our problem here. Exactly. Let's make a screenshot of this thing. That's a fantastic. Now, what is incidence matrix? Incidence matrix give the vertex edge incidence matrix of a graph. Okay, that's related to a graph. Now, graph here means graph theory, which means networks, which means dots and lines. Those are graph. Graph and matrix, there's a kind of tight relation. Although I don't understand exactly. So gives a vertex edge. So each vertex and edge incidence matrix. Oh, okay. So that's not what we want. So we have incidence matrix. Now the other thing we want to know is how do you identify all the, so given a matrix, how do you identify all the same elements, get their row and column coordinate. Yeah, so is there some kind of given a matrix, you want a function to find, oh yeah, I know, cases. So that also useful. Case, the function cases will do that, or positions, exactly. Why don't you show some code so that people understand instead of okay. So let's say we have a matrix here. Let's say, you know, now just two-dimensional matrix. Okay. Now let's say this is our matrix, and we want to know all the position of the character. I mean the number 1. Okay. So let's say equals to, okay, then positions. Okay, this is useful because we will need to identify the coordinates, right? Then we will need to do combinatorics to find all possible pairs of each two coordinates. Then we use the, then we will need this incidence matrix. Okay. Wait, not incident. What is that? The other one we found. What was distance? Okay, where is the distance? Distance matrix. Okay, there it is. Distance matrix between each pair of element. Okay, fantastic. So, oh, so in fact we don't actually need to do the combinatorial pairing. All we have to do is just give the coordinates of all the galaxies. This will compute all the distance for us. Fantastic. Beautiful. Beautiful, beautiful. Okay, but first of all, let me show you this position. Okay, position matrix, and we want to identify, we need a pattern here. So the pattern is just 1. That will return all the matrix positions that matches this this pattern, which is just 1. So if you evaluate that, so let's see what is the evaluate region. So by the way, I'm using Wolfram mod. I'm using Emacs and Wolfram mod. Wolfram mod, here's the source code, 3,000 lines of code, and here's the website. You can go to it. Wolfram mod, what, it's allow you to code Wolfram language, fantastic, in Emacs with flag keys, the most efficient key binding in the universe, more efficient than Vim, than VI, than NeoVim, than EvoMod. Okay, flag keys, that's what I'm using, and I'm using Dvorak keyboard layout. So Wolfram language mod, the code is on GitHub. There you can get it for free. Okay, so now back here, close that. Now we want to run this. Yeah, so now what is the region? Eval region. Okay, tab E. Okay, so you just select that and select that, tab E. Let's see, is the syntax correct? No, the syntax is incorrect. So what is the let's look at the documentation of position function, turn on JavaScript, so Google knows where you live. Position pattern gives a list of positions at which objects. Okay, so we got extra comma here. You see, in Wolfram language, extra comma is not allowed. So let's try it again. Tab E, eval region. There it is. So the first result is the matrix there. The second result is the coordinate where this pattern 1 occurs. So the first one is 1, 3, row 1, item 3, column 3. And the second item is row 2, column 2. Indeed. So that's what you're going to do, okay? So that will identify all the galaxies for our problem, this pound sign. Then you just do distance matrix. You just do distance matrix that will return all possible distances. Then you just sum it up, okay? Which is total. The function name is just total. At least you just return the sum. Why is it not called sum like in Python or other idiotic languages? Because sum, in Wolfram language, you have a function called sum that takes the sum of a mathematical sum. this is a mathematical sum, not total. Okay, so for example, 1 over x goes from let's say 1 to 10. Okay, evaluate that. The result is 7381 divided by 2520. That is summation. Okay, summation, which is I use as my logo, my badge for my website. Summation. Okay, that is why in Wolfram language total is not called sum as in other languages, because this is more proper, because total is actually what you typically mean. You want total things, then sum is a summation. Okay, so but anyway, that's not our problem. So okay, so we demonstrated that. So the first thing is actually to turn this into a matrix. Okay, now let's go back to this problem. So solution, turn the text into a matrix, add extra columns and rows for any empty column and row. Okay, then use okay, then use position to give a list of all coordinates. How do you well, coordinate in a geometry we say coordinate, but in a matrix, how do you call them? The position index. Okay, you call them indexes. Okay, then use distance matrix to get all distances. Okay, then just total. Okay, that is the algorithm. Fantastic, beautiful. Now, so the first thing is turn the text into matrix. Now that we still, is there a convenient way? That's what I'm looking for. Of course, I can start coding and do parse regular expression. Read each line, then go through each character, then push into a matrix. I can do that, but it's not the proper way, especially when you code in Wolfram language, because when you code Wolfram language, the best way to get solution is to think about the problem. You know exactly what you want to do, then half of the time there's one single function to do it. Okay, this is not C. When you start to for loop, oh, this error, for loop, debug, then C, idiots. Okay, so yeah, we want to turn the text into matrix. So I don't think so. Okay, so let's quickly look for list all functions that contains the word text. Okay, text grid, text justification, text line, enter text packet, find image text. Oh, that's artificial intelligence. Return text packet, that's networking programming, text string, text sentences, text structure. What is text structure? Generates a nested collection of text elements. What? Let's have a look. Text structure generate a nested collection of text elements. Object representing the grammatical structure of the natural language text. Okay, that's not what we want. Yeah, it's representing the grammatic structure. Okay, I just want to turn the text into some kind of alignment and padding and vertex texture coordinates. Okay, no, that's the option. Texture mapping. Okay, texture, that's computer graphics stuff. We don't care. It's text packet, text line, string to matrix. Okay, I'm wasting my time here. This is not You know, I'm like just going around. Okay, let's actually code this. Okay, so you want to turn this into a matrix. Yeah, but still. So you want to turn a text into a matrix. Something like string to matrix. Okay, and do we have string to matrix? There's no. String partition. Okay. A C D E F G G G G. Okay, that's getting close. String partition and split string. So you split string and char to string to char. So do we have a string to function? String to byte array, string to stream. You have split string. Yeah, so split string we can use string rifle, string split. Okay, string split. String split. Yeah, pattern. Okay, that's what we want to split at any of the position. Okay, string pattern. Okay, this is not good. I'm wasting too much time. Great, fantastic. I don't know. Hello, I don't know. Hello or Zera. Ziz or Reza. Okay, so oh God, I'm wasting time. How long have been talking? 45 minutes. We haven't even actually begin to code. Let's start to write code, okay? String split, okay? Let's just manually, whatever, you know, stop like talking philosophy, and you know, now let's just get the code going because okay, so we got that we don't distance, we don't care. Yeah, so okay, now evaluate the whole thing. Do we have the right syntax? We do. Okay, it worked. Okay, so string split, print, evaluate it. Okay, so we got, yeah, that's what we want. And then for each we want to you know, we have a function that turns a string, a character, into each array element. I'm pretty sure we have that function. Okay, so here's all functions name, whose name contains the word character. Character counts character. I know there's a function to character code, word character, white space character, character encoding characters. Okay, character string gives a list of characters in string. That's what we want. So let me show you. Okay, so for example, character ABCD. Okay, evaluate this line, and wait, characters, not character, okay, but is there a function with a name character? There it is. Represent a single character in read, okay, that's like, you see, this read is like the Lisp phonetics read macro, you know, read syntax, but that's not what we want, okay, we want characters here. Okay, so you see it turns a string into each character by itself, okay, that's what we want. So first split string, then map, okay, so map a function to this list, okay, then the level we don't care. Now what function? This is the function, okay, so map, so we don't even, so there it is, map, so that will return a matrix already, I think. Yeah, I'm pretty sure that, you know. How elegant. Let's try it. Tab E, eval region, fantastic. Okay, now let me show you this in Wolfram language. Okay, there it is, how beautiful is it? Beautiful. So let's see, so we each, you see, so now we got a matrix. Now we can do this in matrix form, which make it pretty. You see, we got a matrix. Fantastic, beautiful. Now let me do a screenshot of this. Fantastic. Okay, so now we got a matrix. The next thing to do is add extra column. Very easy. So you know, according to this problem, you are expanding the universe. Basically what you want to do is that any column that's empty, you want to add an extra column to it, and same thing for empty rows. Okay, so let's do the row first. So if a row is all empty, then you want to insert a column. Okay, so again, this is a matrix problem, so we need to look at the why don't we show this graph? What is this? Close that. Okay, that is fantastic, showing there, but you cannot see actually. Okay, need to move on. So next problem is to identify all empty rows. Now, is there a built-in function that lets you do that? That's why we are looking at this, all functions whose name contains the word matrix. Now, this is one of the property of Wolfram language. When you code Wolfram language, there is only one thing of concern: function, call function. Okay, nothing else. No objects, no memory, no reference, no pointers, no methods, no class. Nothing. The only thing you needs to be concerned is function. Which function to call, and function, of course, function names, and all function names content are fully spelled out. There's no short, FN stand for function, or DEF stand for define function. Nothing like that. Everything is fully spelled out. That's one of the major properties when you code Wolfram language. Okay, so we are looking at all functions that contains the word matrix, which basically contains which is all functions having anything to do with matrix. Okay, and now we need to find, we kind of need to identify all rows whose entry are of the same entity, which is a dot. Okay, or we want to identify Now, okay, so now this problem, usually you want to think of the problem in terms of mathematics, because once you know if this is common thing in math, then you know there's a function. In this case, to identify the same elements is so you do have identity matrix. You see, you have symmetric matrix, square matrix, we don't care, a Sherry matrix, that's for transformation, unitary matrix. Okay, unitary matrix convert the unitary matrix to a structured array. I don't know what that means, unitary matrix. Okay, what is a unitary matrix? Oh, that's like basically a matrix that means one in complex field, complex numbers. Okay, distance matrix, disk matrix, diagonal matrix. Whether it's diagonal matrix or not, we don't care. We want to find the empty rows and empty columns. Okay, orthogonal matrix, I don't think we care about that. Converts the orthogonal matrix to a structured array. Now, what does orthogonal converts orthogonal? Orthogonal matrices, when represented a structured array, allow for a convenient specification and more efficient operations, including inverse and linear solve. So, what matrix decompositions that use orthogonal matrices? What? Oh, okay, so orthogonal matrix is, well, it's like linear algebra. The property of these elements, they are linearly independent, both vertically and horizontally, something like that. So but what they mean by array, I mean, oh, this is new in 14, experimental. Okay, we don't care about that. New in version 14. Version 14 just came out like a year ago. So distance. So whenever it's new, usually we don't care, because new, it's not classic. New is like, let's see, cross matrix. Cross matrix gives a matrix whose elements are one in center cross shaped. Okay. Cross matrix gives a matrix whose elements are one in a center crossed shaped region that extends R positions along each index direction and zero otherwise. I don't understand. Oh, okay. Literally across. So this function cross matrix generates a cross matrix, but band. Okay, let's look at band. Band ij represents a sequence of positions on the diagonal band. Okay, no, that's not what we want. We need straight columns, and so you got minus, you got okay, again, I'm talking too much. Now why don't we just start to actually code instead of so we need to find empty columns and empty rows, right? So empty columns and empty rows. Oh shit, I'm gonna take more than 1 hour today for this adjacency matrix. Okay, view matrix. Okay, so permutation, reflection, negative matrix plot box matrix. Let's see distance. I don't know. I don't know. So I mean, I can start to code it, or I can look for the proper solution. You know, I can start to code it just by going through the matrix and get the first, you know, like do a loop or a map. So but let's focus on a row first. So you want to repeat empty rows. I mean, rows, that's just a dot. So how do you do that? Well, you can map. Okay, well, you can do a map. Okay, so you can do map, one of the map function, map at, map thread, moving map, parallel map, map all. Oh God, I hope I finish this today. Okay, let's just code. Let's not fuck around. Let's just code. Code. Okay, so code. So you want to find all empty matrices, empty rows. So for each empty row, you okay, let's just do it. Okay, so we can do replace all. Okay, that's kind of a find and replace. Okay, expression rules. Okay, expression rules. Okay, that's what you need to do. So let's say matrix equals to that. Okay, that's our matrix. Then replace rules. So what we need to replace this matrix. So the rule is that empty row. Okay, so we're gonna have a pattern here, and we name the pattern empty row. So what is the pattern? The pattern is gonna be like that, and each item is a dot, and repeat it. Okay, so that is how you find an empty row. Okay, so once you find it, you want to replace it by, this is pattern matching, structural symbolic pattern matching. You can think of it like a regular expression, except regular expression is for text only, for string. In Wolfram language, everything is a symbol. The whole language, the entire source code is, you know, like structural symbols. So you can directly replace the, you know, the structure, kind of like syntactic manipulation. And in Lisp, in a very low level, I mean in a very weak form, it's called Lisp macro. Okay, So anyway, that's what we are doing. We are doing symbolic replacement. So each empty row replaced by two empty rows. Let me show you how that's done, okay? So a list empty row and empty row, okay? So let me show you. So there it is, okay? This replace all. Let's say X matrix equals true, okay? So let's see. You know, this is, okay, let's, anyway. So replace all a matrix, then we can try it. Let's see if that works. I think it would, okay? Yeah, let's try it here in Wolfram language. Let's just paste it here. Fantastic, okay? Now let's do matrix form. Okay, now this matrix form, so it's easier to see. Fantastic. Now we got a problem. You see, now this row we repeat it, however it become kind of it became kind of like nested, so we don't want that. So in order to, we need in JavaScript it's called triple dot operator. Let's go JavaScript tutorial. It's called, what is it called? The triple dot operator, okay? Iterable object, okay? Spread operator, the most idiotic name in JavaScript. But anyway, so in Lisp you also have that. Usually it's called anyway, in Wolfram it's called sequence or splice, okay? So let me just do it. Splice sequence, okay? So let's look up the documentation. Sequence represents a sequence of arguments to be spliced automatically into any function, okay? Now this one is new in 1996. That's what I want. Now let's look up a related thing is splice, okay? Splice into any list which is appears as sequence, okay? Splice is 2020, so sequence is what we want. Represent a sequence of arguments to be spliced automatically into any function, meaning remove the brackets or the braces, so a list becomes just a bunch of arguments. So that is sequence, okay? That's what we want to use. So here you say sequence, okay? What? Wait, God. What? Why is it not? Anyway. I believe like that, okay? So let's try. No. Oh yeah, wait, what? Wait, the syntax is not correct. There it is. I believe that's it. So yeah, this is original, this is a new. You see there's two empty lines we added. Okay, so that's fantastic. Now we need to do the same thing for row. So we can do it, but an easier way is just to transpose the thing. Okay, so let me just do my things because we are getting too long. Transpose. Okay, so we want to transpose the matrix, then do exactly the same thing again. Okay, let's forget about form and elegance. Let's start to just quickly get this going. Okay, so you transpose the matrix, then you do the same operation, then you transpose it back when you are done. Okay, so that should do it. Okay, let's the matrix form here is annoying. Okay, so basically that is our code. Let's do it again. No, something is wrong. Transpose twice. Why? Oh, the matrix form. God. Yeah, well, because of the wait, that should work. Transpose the matrix. You transpose the matrix, then you do replace all. Then you transpose back. So why? So why? So why is this showing that? Oh, because you attach, yeah, so this is already stupid, so we don't want that. You know, you don't want this matrix form to be part of the assignment. That is why. Okay, let's evaluate it again. There it is. Fantastic, beautiful. Okay, so this is, so you can see there's also a double column here, so that is, we completed our job. Now we can, you know, we can kind of clean this code. Yeah, but let's not. Okay, let's move on. So let's try to solve the problem. So we padded, then okay, solution. Okay, solution, put it to top. So we padded them, we expanded the universe, then this test code we don't need. Okay, now you need to get the position. You need to find all positions of that. Okay, let's try that. What? Not here. Here. Paste. Empty. Oh yeah, the variable name is X matrix. Oh wait. Okay, so let's do this all again. Paste, run. Fantastic. Okay, so this exactly, this is all the positions of the galaxies. That's their coordinate. Okay, fantastic. Now so what's next? Then distance. Okay, let's try it. Okay, so wait, so distance, my matrix, then you want to identify all pound sign. Okay, I believe, paste it here. Okay, 0. So what is the documentation for distance matrix? Maybe we misunderstood. Oh, okay, so you need what? Maybe this is not what we want. So distance matrix gives the matrix of distance between each pair of elements. Okay, so what does it take? I'm not sure, so let's try. Okay, there it is. Now, so what? Okay, so it just take one matrix and it returns this this distance. So what does this mean? Distance matrix. Okay. So distance matrix gives the matrix of distances between each pair of elements. Each pair of elements. What? What is that distance? I don't understand. So let me show this. Okay. So so that so that okay, then position, let's try that. There it is, much easier to read. So we begin with this, then we expanded the universe, then we also expanded vertically. Then here's the identification of all the galaxies. Then here is the distance matrix. This part I don't understand. What is it? Okay, so you need to, okay, so okay, now we are trying to find a pattern between this one and this one. What does it indicate? So here's 2, 2, 1, 1. It doesn't, I don't know what is the distance matrix. The distance function. So what is the distance? Gives the matrix of distances of each pair of elements. Ui and uj. Okay. Oh, okay, so but does anyone watching, anyone like continuing watching this episode? Now my coffee is gone. Yeah, but I need to finish this. I want to have a break, but I need to finish this. So right now we are trying to figure out what exactly this distance matrix is doing. It seems to be related to our issue. Our problem is that given any two pound signs, we want to know their distance. So this distance matrix seems related or can do what we want, but we are not sure. Distance matrix, you see, it takes a bunch of arguments. Now I don't know if those arguments are just elements in the matrix or it's just the whole matrix between each pair of elements. So between each pair of elements, so I don't understand. So let's see, let's say distance matrix. 1, 2, 3, 4. Let's see what it does. What? So it always return a matrix, but the input may be a one-dimensional matrix or it may be two-dimensional matrix. Okay, this is confusing. When is this function introduced? This is introduced in 2015. Okay, adjacency matrix, nearest norm, closed. Okay, find cluster distance function. Okay, distance and similarity measures. Okay, so our problem is to identify. Okay, we can ignore this function and just manually code it. It's not difficult. So let's see, compute a distance matrix from a list of integers, 0, 1, 1, 2, 3, 4. So you got, yeah, but I don't understand why, what distance, because a distance implies two things. So is that a combination of all these possible numbers, and what is meant by distance by them? Okay, so this distance function seems AI is machine learning thing. Oh, okay. Yeah, this is actually a machine learning thing. Okay. Now I don't understand what exactly it is. Distance function. So if you look up distance function in machine learning, I think it'll tell you. Okay, so let's try to quickly see if that makes sense. Distance matrix of machine learning. A distance matrix is a fundamental concept in machine learning, particularly in clustering, dimensionality reduction, okay, and other unsupervised learning techniques. Here's a comprehensive overview. What is distance matrix? A distance matrix, also known as a dissimilarity matrix, okay, or similarity matrix, is a square matrix that represents the pairwise distances or similarities. Okay, so distance here means similarity. Okay, so it returns a pairwise similarity between a set of objects. Okay, data points or samples. Okay, so for example, you have an apple and you have an orange. There's a distance between them. Here, distance means similarity. How similar are they? Versus, as say an apple and a cat and a dog, a house and a car versus an apple. So this gives a number to indicate similarity. Okay, now but why is it a matrix? Because if you have a list of things, let's say if you have three things, you have 1, 2, 3. You have three pairings. So if you have four things, how many pairings 4 out of 2 combinatorics, okay, which is 12, I think. So when you have 4 things, you have 12. You know, we are kind of digressing, but distance matrix always return a square matrix. So that's what the part I don't understand. Why does it return a matrix? A distance matrix, okay, so data point sample. Each entry in the matrix represents the distance or similarity between 2 objects. Okay, but which 2 objects? Oh, so the matrix is always symmetric, okay? No negativity, 0 diagonal, okay? That all works out. Okay, so that's not what we want, okay? Let's not, you know, digress. Let's get back to our problem. Our problem is to find the actual distance, so that's easy. So what we have to do is, first of all, identify all the positions, okay? This function will give you all positions. Now, each position, each coordinate, each pair of numbers here represents a node. I mean, represent a galaxy, you know, this pound sign symbol. And now you want to find all possible pairings between them. That's easy. There's a function to do that. So let's see what that is. Okay, I believe the function may be named tuple. Tuple list and generate the list of all possible n tuples of elements from list. Okay, let's try. Tuples A, B. Okay, tuples you need, oh yeah, you need 2, okay. So A, B, B, okay, that's all possible tuples, okay, but we only want unique items. We don't want the order doesn't matter. So there's a permutation, there's a subsets, I believe it's a subsets. Subset n give a subset containing at most n elements, okay? Give a possible or subsets. No, that's not what we want. Binomial, there's a permutations and combinations. Let's think. So possible all pairings, so order doesn't matter. So it's like given n things, you want to take 2 and order doesn't matter, okay? So that would be called combination, okay? I believe that's called combination. Permutation, so we have permutation subsets, list of all possible subsets, list of all subsets containing at most n elements. That's what we want, subsets, okay? Let's try. Yeah, let's try subsets. Let's say A, B, C, D, E, F, G, okay? 2. Okay, so yeah, so that's what we want, but however, it also includes 1 element, but we always want just 2 elements, so that's how you do. So there it is, A, B, A, C, A, D, A, E, okay, that seems to be what we want, but too many. Let's reduce the items so we can actually see, verify. So A, B, C, D, you got A, B, A, C, A, D, B, C, B, D, C, D. That's what we want. 4 things. The combination is then 4 times 3 is 12. Then order doesn't matter, divided by 2, so you got 6. 1, 2, 3, 4, 5, 6. So that's what we want, subsets. Okay, So you just want to take the subsets of these positions, okay? Let's give a name. Let's say coordinate list, okay, equals to that. Then you just need to say subsets. Okay, subsets, only two possible things. Okay, so that's what we want. Wait. Positions, position, what? You got positions, then you want subsets. Okay, so subset, okay. Oh yeah, so we got the syntax wrong, so there, and there, no. What is this? Subsets, not subset. You're missing S. So why is it? Okay. So you yeah. So S. We are missing S. Okay. So let's try again. That's what we want. So each item here is a pairing, is a possible pairing between two galaxies. Okay. Now we just need to find the distance. Okay. So the distance is, okay, so let's copy that. So we're starting to get too long, too tired. So, but, yeah. So one pairing is like that, okay, so let me just show you. So one of the pairing is like that, so the distance is you apply a function, so let's say replace all we just want to replace at level 1, okay, so replace rules level spec 1, okay, replace apply rule or list of rules in attempt to transform the entire expression, okay, here by default apply rules only to complete expressions, okay. So for example, let's say A, B, C, A, okay. Now replace A, replace by 3, okay. Evaluate it. That didn't work. Why is that A, B, C, A that didn't work? Because is that because you need a list here? No. this is taking too long. Shit. 90 minutes already. Now why is this not working? Now I'm got impatient now. Need to finish this talking too much. What? That illogical. Why is that not work? Replace ABC A. Okay, that should work. Now there's something fundamental I'm kind of missing or something. The rule should be this form. A list of rules can be given. The rules are tried in order. The result of the first one that applies is returned. Okay, if none of the rule applied, the original expression is returned. Yeah, but we do have apply. Oh, okay, so we didn't specify a level. That's right. Okay, so there, you need the level 1. There it is. Beautiful. Did you see it? Yes. Okay, so we are, I'm being very specific if you know Wolfram language, because typically you use replace all, but I'm being very specific. But anyway, so we have this, this is how you do kind of like list marker, okay, syntactic replacement, okay. So, but now we want a form, we want a pattern. The pattern will be like that. So A, okay, so B is an integer, then C, D, okay, A, B, C, D. We have a pattern like that, and we want to replace it by distance, okay. Let me show you. So here we are gonna compute the distance. So AB is a coordinate. So yeah, remember the way to compute distance, because our talk show is this diff row number and diff column number. So A minus C absolute. Okay, so it's gonna be replaced by absolute A minus B plus, is it plus? Yeah, plus, okay, plus B minus D, okay, A, C, B, D, okay, A, C, B, D. Okay, so let's, okay, so this is a rule, okay. So now, well, actually, so wait, let me show you. So actually, it should be, that is the pattern. This pattern will get replaced by that, okay? And here is the expression. Okay, so this is our matrix. So actually not the matrix. We want this subset, this coordinate thing. Then we just total this and that's it, okay? So this, now let's just start to quickly code. You don't know what I'm doing, but that's okay. So we got the coordinate list, then you get the subset, subsets, okay? Subset is galaxy pairs. Okay, that's the list of pairs of all galaxies. Okay, then you just do you replace, you don't care, this no, then you just put that there. Okay, you, for all pairs of the galaxies, whenever you see this pattern, you replace by their distance. Okay, let's see if that works. Okay, so let's try galaxy pairs, evaluate. Okay, let's magnify one more time. Okay, that's a list of galaxy pairs. Then all we have to do is just do this replacement. Replace all the galaxy pairs by their distance. Then just total. Okay, total. Okay, percent sign means the last output. Shift enter. 374. 374. Is it correct? Please let it be. I'm done with this problem. I got tired. Are you working on solution again? Yes. Zelda or Zelta, whatever. Check YouTube. Okay. Where's my YouTube? Let's see. What's the problem? The Google Chrome. Okay, advent of code. So 374, fantastic and beautiful. Now we're gonna work on our problem. Okay, 374, fantastic. Now we just compress all these things into one single line and solve our problem. Okay, so yeah, okay, so wait, so you need to get the total. So okay, not distance matrix. We need total. That's right, total at that. So result equals to that. Okay, and that's it. Okay, that's a solution. So so this is a solution. Let's compact it. Let's compact it. Now we need to read the problem into a string. Okay, let's put it back. So here is today's talk show. The problem URL, the description, the algorithm steps, and our code for this toy input. Now we just need the real input. Now the real input is, we saved it here. Yeah, copy the file path, close that, and make a backup, and let's start to put out again. So the input, we'll need to read the input. So how do you read the file? I don't remember. So Wolfram language. So let's go to, if you just search for XR Wolfram tutorial, you'll find it, and what we need is to read. Okay, so just search for read file. Why is it why cannot you find read function, pattern matching, advanced data structure, symbol, principles, load file? Okay, load file is not what we want. We just want to read the text file. So okay, I need to add. So you can find it by shell tasks. You go to shell tasks, then you have list files, list file path functions, delete the is file directory, file exists, check file date, read file, there it is. Okay, I need to kind of make this page a link in the panel so it's easy to find, because this is a general. So anyway, read string file path. Okay, so read string. So x input equals to read string, and here is the file path. There it is. Let's copy it. Let's see if it works. Okay, that works. That, huge file. Yeah. Okay, let's delete that. Yeah. Delete that. So we read the string. Actually, we don't have to go to the node. Let's just run it here. So we got the input. Okay, so input, then we set the matrix, then matrix equals to that, then matrix equals to that, then colon. Okay, so so if we just run this, do we get the result? Okay, result equals to total, and then print result. Okay, let's run this. Let's just run it. 376 or something. 334. 334, correct. Now let's use our own input. Okay, so the input now is this read file. Run it. Okay, 974. The solution is 9742154. Submit. That's the right answer. Of course, one-shot solution. Fantastic. Now, who is watching here? Say hi, okay? Give me some high five. Finally, we solved it. And we can do more by, I can kind of go explain and lots of simplification, okay? Lots of the, this code, for example, let's put it back. Where's the solution? So my solution is output. Yeah, so there is a solution. Close that solution. Let's say my solution, okay? So that is a number. Now let's put it back. Syntax correct, show in browser. That's today's problem and today's code. Now this whole thing is just one single line, okay? You can just make it one single line, no more than 80 characters. Yeah, no more than, let's say, 100 characters. So I can continue to do that, or that'll be it. That's it for the day. I mean, so what should I do? Should I continue to kind of summarize and compact the whole code into one single line of no more than 100 characters, or this is, so those of you watching, congratulations. Thank you, Turjack. We got it. Okay. Let's see. Okay. And I'm tired, so I think that's it. That's it for today. Unless, someone wants me to continue on the technicalities, on the wonders, the fantastic, wonderful, the science of programming, the science and art and the mathematics of programming. Fantastic. Hearts. Okay, where's my Google thing? Let's see, day 11. Okay, so let's see, 5 people watching. Oh, okay. Okay, that's it for today, I guess. We shut down, unless otherwise, we shut down in 1 minute or 2, okay? This solution, I really need to make it simpler. Yeah, but let's not. And there's also lots of other ways to do this. Anyway, yeah, that's it for now. Thank you, guys. If you guys like my stuff, always go to my website. Go to it, xali.info. Just search for it, you'll find it, and you'll find this page, XA code, and you scroll down. Here's a Chat GPT introduction of myself. What Chat GPT thinks of me. Because I have a big website, so Chat GPT grabbed all text on my website. So when you ask Chat GPT something, remember, I'm part of the answer. Chat GPT integrated. So anyway, go to the bottom, so you can Patreon me, okay? Amazon gift card me, PayPal me. Let's see, Patreon. Who has got, $1,005 a month, okay? Yeah. Okay, thank you, guys. Bye, guys. Where we expose products and software dev and their stupidity. Okay. You gotta be more specific. Well, anyway, let's talk next time.